So today let's discuss questions related to analytical geometry that were asked in recently conducted examination of UPSC CSE. So there were total 5 questions asked related to this topic and the total weightage is 60 marks. And in that 3 were 10 markers and 2 were basically 15 markers. So let's see them one by one. So the question 1 says that find the equation of cone whose vertex is this and whose guiding curve is this. So they have given us vertex as 1, 1, 0 and our guiding curve is y equals to 0 and x square plus z square is equals to 4. So let us assume that L, M, N be direction cosines of generator. So if that's the case, then my equation of generator would be x minus 1 by L is equals to y minus 1 by M is equals to z minus 0 by N, because my generator will be passing via vertex of cone as well. And if you observe that the guiding curve is given to as this and generator must be intersecting the guiding curve, so the guiding in the generator line we can substitute y equals to 0. So if we do so, we'll get x minus 1 by L is equals to minus 1 by M is equals to z by N. So from here I can find out a value of x and z. So that would be x equals to 1 minus L by M and z is basically minus N by M. Now I can substitute this value of x and z in the guiding curve. So that gives me x square plus z square is equals to 4. So from here I'll get 1 minus L by M square plus minus N by M square is equals to 4. And if I simplify it, I'll be getting 1 minus from this generator line that I have assumed. L is basically x minus 1 and my M is y minus 1. Likewise my N is z and my M is again y minus 1. So if I simplify it, it will be basically y minus x square plus z square is equals to 4 into y minus 1 whole square. So this is basically the required equation of cone which is passing via this guiding, which has this as guiding curve and this as vertex. So it was a fairly easy question. So let's move on to next question. So the next question says that find the equation of cylinder whose generators are parallel to this line, and it is also given that the generator passes via this. So this basically acts as guiding curve to the cylinder. So let us assume that x1, y1, z1 be any arbitrary point on the cylinder. Arbitrary point on cylinder. And if that's the case, then equation of generating line would be, equation of generating line will be basically x minus x1 by 1 is equals to y minus y1 by 2 is equals to z minus z1 by 3. Because my generators are parallel to this line, so the direction cosines of generator line would be 1, 2, 3. Now let us equate it with some constant k, and from here now I can find out any arbitrary point lying on the generator line. So let's name it as A, and any arbitrary point on generator line would be basically k plus x1, 2k plus y1 and 3k plus z1. So this is basically any arbitrary point on the generating line. And the question says that generating line passes via this curve. So the guiding curve is given to me as, it is z equals to 0, x square plus y square is equals to 16. Since in guiding curve z is equals to 0 and the generating line is intersecting the guiding curve, so from here I can equate the z ordinate of point A with 0. So if I do so, I will be getting k is equals to minus z1 by 3. And these x and y ordinates must be satisfying this because the generating line is intersecting the guiding curve. So using that, I'll be getting k plus x1 square plus 2k plus y1 square is equals to 16. So if I substitute this value of k here, I'll be getting x1 minus z1 by 3 square plus y1 minus 2z1 by 3 square is equals to 16, which basically gives me 3x1 minus z1 square plus 3y1 minus 2z1 square is equals to 16 into 3 square, that is 9. So basically my equation of cylinder is 3x minus z square plus 3y minus 2z square is equals to 144. So this basically gives me the equation of cylinder, because I have assumed x1, y1 and z1 to be any arbitrary point on the cylinder. So this is the required equation of cylinder. You can just simplify it by opening the whole square using a square plus b square plus 2ab thing. So let's move on to next question. So the next question says that find the shortest distance between the straight lines this and this. So line 1 is given to me as x minus 3 by 3, y minus 8 by minus 1 equals to z minus 3 by 1. So any arbitrary point, if I equate it with k1, so any arbitrary point on line L1 will be basically 3k1 plus 3 minus k1 plus 8 and k1 plus 3. Likewise, line 2 is basically given to me as x plus 3 by minus 3 is equals to y plus 7 by 2 is equals to z minus 6 by 4. Let's equate it with k2 and find out any arbitrary point. And let's name the arbitrary point as b. So any arbitrary point would be minus 3k2 minus 3, 2k2 minus 7, 4k2 plus 6. So the shortest distance line will be basically perpendicular to both lines L1 and L2. So let's find out. Let AB be shortest distance line. Shortest distance line. So we have a parametric form of coordinates of A and B. So the direction cosines of AB will be basically 3k1 plus 3k2 plus 6 minus k1 minus 2k2 plus 15 and k1 minus 4k2 minus 3. So if this is the direction cosine and it must be perpendicular to both line L1 and L2. So using perpendicularity result, that says L1 L2 plus M1 M2 plus N1 N2 equals to 0, and these have usual meaning. So this gives me 3 into 3k1 plus 3k2 plus 6 minus k1 minus 2k2 plus 15 plus k1 minus 4k2 minus 3 equals to 0. So if I simplify it, I'll be getting 9 plus 1 plus 1 k1 plus 9 plus 2 minus 4k2 plus 6 is 18 minus 15 minus 3 is equals to 0. So if I simplify it, will give me 11k1 plus 7k2 equals to 0. Likewise, AB is perpendicular to line L2 as well. So from there I'll be getting minus 3 into 3k1 plus 3k2 plus 6 plus 2 into minus k1 minus 2k2 plus 15 plus 4 into k1 minus 4k2 minus 3 equals to 0. And if I simplify it, I'll be getting minus 9 minus 2 plus 4k1 plus minus 9 minus 4 minus 16k2 plus minus 18 plus 15 to the 30 minus 12 equals to 0, which basically gives me 11 minus 4 minus 7k1 and minus 29k2 is equals to 0. So now I can solve star 1 and star 2 for k1 and k2, and if I solve, so from star 1 and star 2, I'll get my k1 is equals to k2 equals to 0. So from here I'll be getting basically point A and B, which basically gives me the coordinates of shortest distance line. So my point A is basically 3, 8, 3, and my point B is minus 3 minus 7 6. And in question I am supposed to find the shortest distance. So shortest distance will be is basically the distance between point A and B, and that is 3 plus 3 basically 6 square, 8 plus 7 15 square, plus 3 minus 6 minus 3 square. And if I simplify it, I'll get 36 plus 2 to 5 plus 9. So it is under root 270. So I can write it as 3 into 90 is equals to 3 into 30. So it is basically 3 under root 30 units. So this is the shortest distance between the two given lines, and it's a repeated question. It's asked approx 2 to 3 times previously as well. So let's move on to next question. So the next question says that find the equation of sphere which pass through this circle and touches this as plane. So equation of any sphere passing via given circle would be x square plus y square plus z square minus 2x plus 2y plus 4z minus 3 plus lambda into 2x plus y plus z minus 4 equals to 0. And if I simplify it, I'll be getting x square plus y square plus z square plus x into 2 lambda minus 2 plus y into lambda plus 2 plus z into lambda plus 4 plus minus 3 minus 4 lambda is equals to 0. So center of any such sphere would be 1 minus lambda minus 1 minus lambda by 2 and minus 2 minus lambda by 2, and radius will be basically 1 minus lambda square plus minus 1 minus lambda by 2 square plus minus 2 minus lambda by 2 square minus the constant term, that is minus 3 minus 4 lambda. This will basically be 3 plus 4 lambda. And the question further says that this equation of sphere touches this plane. So if this touches the plane, so the perpendicular distance from center of sphere to this plane must be equals to radius. So let's see what is the perpendicular distance from center C on the sphere, that is 3x plus 4y equals to 14. So the perpendicular distance is 3 into 1 minus lambda plus 4 into minus 1 minus lambda by 2 minus 14 divided by under root 3 square plus 4 square. So radius must be equals to this perpendicular distance. So from here I'll be getting 1 minus lambda square plus 1 plus lambda by 2 square plus 2 plus lambda by 2 square plus 3 plus 4 lambda is equals to 3 minus 3 lambda minus 4 minus 2 lambda minus 14 upon 5 square. So this basically gives me 25 into 1 plus lambda square minus 2 lambda plus 1 plus lambda square by 4 plus lambda plus 4 plus lambda square by 4 plus 2 lambda plus 3 plus 4 lambda is equals to, on left hand side it will be 3 minus 1 minus 15 and minus 5 lambda square. So if I simplify it is 25 into lambda square plus lambda square by 2 plus this 2 lambda balances this one, lambda plus 4 lambda, that is 5 lambda, and 1 plus 1 2 plus 4 6 plus 3 9 is equals to, I can take 5 common, so I'll be getting 25 into lambda plus 3 square So this 25 balances this one. So I am left with 3 lambda square by 2 plus 5 lambda plus 9 is equals to lambda square plus 9 plus 6 lambda. So this basically gives me lambda square by 2 minus lambda is equals to 0. So from here I got lambda into lambda by 2 minus 1 equals to 0. So I got basically two values of lambda. One is lambda is equals to 0 and another is lambda equals to 2. So I'll be getting two equation of sphere. So the required equation of spheres are x square plus y square plus z square. Sphere 1, let's name it as S1, minus 2x plus 2y plus 4z minus 3 plus lambda into 2x plus y plus z minus 4. 2x plus y plus z minus 4. So at one time I'll be taking lambda as 0. So the required equation of sphere S1 is x square plus y square plus z square minus 2x plus 2y plus 4z minus 3 equals to 0, and another equation of sphere, let's name it as S2. So that would be x square plus y square plus z square minus 2x plus 2y plus 4z minus 3 plus 2 into 2x plus y plus z minus 4 equals to 0. So these are the two equations of spheres that I'll get. So let's see the last question. So the last question says that show that there is no tangent plane to this sphere that can be passed through the straight line. So what we can do is we can assume that there exists a tangent plane which contains this line, and then we can get to some contradiction. So let us assume that, so for the given equation of so the tangent plane is passing via line x plus 6 by 2 is equals to y plus 3 equals to z plus 1. So the given equation of line is in symmetrical form. Let's just convert it in unsymmetrical form. That would basically give me x plus 6 equals to 2y plus 6 and y plus 3 is equals to z plus 1. So if I simplify it, I'll be getting x minus 2y equals to 0 and y minus z plus 2 equals to 0. So the tangent plane to this sphere will be passing via these two lines. So let x minus 2y plus k into y minus z plus 2 equals to 0 be the tangent plane to the sphere. So if I simplify it, I'll get x plus k minus 2 into y minus kz plus 2k equals to 0. So this is acting as tangent to the given sphere, that is x square plus y square plus z square minus 4x plus 2y minus 4z plus 4 equals to 0. So center of this sphere would be 2 minus 1 2 and radius would be basically under root 2 square minus 1 square 2 square minus the constant term 4. So this adds up to under root 5. So if star is acting as tangent to the sphere, then my radius, that is under root 5, must be equals to the perpendicular distance from center to star 1. So that is basically 2 minus 1 into k minus 2 minus k into 2 plus 2k divided by under root 1 plus k minus 2 square plus minus k square. So we can just solve it to get value of k. So we can take square of both sides. So we'll be getting 5 equals to 2 plus 2 4. This 2k balances this one. 4 minus k divided by under root 1 plus k square plus k minus 2 square whole square. So if I simplify it, it will be 5 into 1 plus k square plus 4 minus 4k is equals to 16 plus k square minus 8k. So if I simplify it, it is 5 into 2k square minus 4k plus 5 equals to k square minus 8k plus 16. So this basically gives me 10k square 20k plus 25 equals to k square minus 8k plus 16. This is equals to 9k square minus 12k plus 9 equals to 0. So we can divide throughout by 9. We'll be getting 3k square minus 4k plus 3 equals to 0. And it is a quadratic equation in k, and so we can solve it for k. So k will be basically 4 plus minus b square minus 4 into a into c divided by 2a. So this basically gives me k equals to 4 plus minus 16 minus 9 4 36 divided by 6. So it is 4 plus minus under root 20i by 6. But these two values of k are not real, so there does not exist any such k for which this star one acts as tangent to this sphere. So this shows that there is no such tangent plane. So there does not exist any tangent plane passing via given line. And touching the given sphere. So these are the 5 questions that were asked in 2025 examination of UPSC, and these were fairly simple questions. If you have done the previous year questions carefully, then you can easily solve all the 5 questions. So that's all for today. Thank you for watching.